Hello everybody, this is Seizure Detection Band version number 1. Alright, so currently it is a very simple version. So it's an ESP32 motherboard connected to an accelerometer. This accelerometer detects the shaking motion so that when it has a seizure, the ESP32 calculates at the percent of seizure. The ESP32 uses Wi-Fi to determine the approximate current location of the person, and it also sends out an email to the user telling them that they had a seizure. Alright, so let's get started. So in order to actually use this, well, this is supposed to be a band, but since this is just the first prototype, it's just a breadboard form right now. But if I shake this, I might just skip this part for a while. If I give this a shake as if someone's having a fit, then what will happen is there will be an email sent to the user. Alright, so I'll see it when it's sent. The shaking causes this email to be sent to the receiver, saying seizure detected and the time, the longitude, and the latitude. As you can clearly see, this is powered by a program called IFTTT, which we will go in later depth later in the video. Also, as long as everything coded does go perfectly fine, this email should only, and I mean only, be sent when the user is in fact rapidly shaking, not when he's just standing still, or not when he's just moving around. We'll show the code for that later into the video. Alright, so here we have a diagram of the wiring for this model. So the ESP32, it's a microcontroller that is connected to Wi-Fi, is hooked up to the MPU 6050 accelerometer. Excuse the low quality, but the SCL and SDA pins are connected to D21 and D22 on the ESP32. The VCC is connected to 3 volts 3 to get power, and ground's connected to ground. It's quite a relatively simple wiring scheme. However, that's all that's required for a simple iteration like this, where all we need is a microcontroller that has access to Wi-Fi and access to accelerometer data to detect when the user is shaking.